Ayan, so good afternoon everyone. So again, naka-flash ulit dito yung ating syllabus. So ngayon, CU1, course outcome 1 natin is just the differentiation ng different gas turbines and yung construction nila. Ito. So, well, ito. Pag dinescribe na natin yung construction, then yung operating principle, madadamay na natin yung 1.2. And yung disadvantages niya sa steam turbine, which is also iaano natin mamaya. We'll discuss ilang oras ba tayo. So we have 2 hours. Let's see if we can fit all those 3. Parang tig to 30 minutes halos. So, actually, yung 4, ma-identify na rin natin yung components pag pinakita ko na sa inyo. So, we'll be actually hitting more LOs than we expect. Okay? So, ito, generally, makikita nyo yung, ano natin, makikita nyo yung direction where we are going. Okay? Especially na yung ating instructional materials ay hindi pa fully migrated. So, anyway, dito lang din man binabase yun. So, describe natin muna yung types of gas turbines. So, eto. Ngayon, yung gas turbines natin, it is actually not used much on board. Your merchant vessels, wala masyadong gumagamit niyan. So, wait lang ha. Let me just search dito. Ito nakita nyo. Ang gumagamit lang madalas ng gas turbine are warships and a few passenger ships. Okay so let's put it into context. Yung gas turbine natin, hindi siya nagagamit or hindi siya ginagamit ng merchant vessels. It's not feasible enough to use as propulsion system. Iilan lang yan. So, sa merchant vessels, sa buong fleet, if I remember correctly, yung classmate ko na nagtatrabaho ngayon sa dagat, sabi niya, there are only around 100 ships. Out of, sabihin natin, you have 2 million ships at any given point. So, i-divide natin yung 100 sa 2 million. So, that's going to be 0.005. Ganun lang siya kaliit. That means, yung percentage niyan sa total fleet, that is 0.005% of the total fleet that goes out at sea. Nakikita niyo context niya. Hindi ko naman sinasabi na hindi mahalaga ang PASGT. Well, mahalaga siya in a sense dahil inaaral natin siya. Pero, ironically, hindi natin siya makikita on board. Ang pinakamalapit na makikita nating iteration ng isang turbine ay sa turbocharger. And sa steam turbine, if your ship possesses one, and not all ships will possess a gas turbine and a steam turbine. But turbochargers, yan. Meron yan. So, yung some of their principles will overlap. Okay? So, kung makikita nyo dito sa picture, ito yung itsura ng ating gas turbine. Mamaya natin yan i-dive in. So, punta muna tayo sa gas turbines na ginagamit. Ngayon, kung nakakita na kayo ng eroplano, nakita nyo nasa pakpak nila. Nakikita nyo ba yung nasa pakpak yung sa gilid nila?
Ay, sir.
Ay, sir.
Oh, that's an example of a turbine. Turbina 'yon. Ngayon, hindi mo pwedeng gamitin yung diesel engine basta-basta doon kasi for that size, mabigat masyado. Saan lang ba nagagamit ang gas turbine muna? So, let's go to the applications. Ito, sa power generation yan. Sa mga chemical plants, saka sa mga refineries. So, ito, hindi lagi siyang ginagamit sa barko. Mas actually ginagamit siya sa lupa. Yung fuel kasi nito, actually yung fuel nito LPG is, how would I put it? Hindi rin siya readily available. Sa totoo lang. Doon kasi ano dito sa gas turbine mo, you're using gas, hindi naman necessarily as gasolina ha. Gas meaning in gaseous form. Your fuel is in gaseous form. And it's also mixed with the air and later on, fired up para magkaroon ng combustion. Pero compared to your diesel engine, mas mababa pa rin ang efficiency ng iyong gas turbine. Mas mababa siya. Pero pinakamadalas siyang ginagamit sa aircrafts, sa eroplano. Ayan, makikita nyo, jet engines, yan ang madalas makikita nyo na pinagagamitan. Wala kayong masyadong makikita. As I said, that's 0.005% of the total fleet. At napakaswerte mo kapag nakasakay ka dun. Kasi napakabihira niya. But 95% of the time, you will be boarding a marine diesel engine driven ship. Okay, malinaw ba? So ito. So you have here, yung unang type natin is the turbojet engine. Ito yung pinakaunang gawa. Ito yung pinaka first iteration niya. Sir, paano po yung cycles niyan? As you can see, the cycles are still the same. Meron kang intake, meron kang compression, you have power, and you have exhaust. Ang pinagkaiba lang nila, wala kang reciprocating motion. Yan, lakihan natin. Mas kita nyo na ba? Mas malinaw? Okay.
Ay, sir. Ay, sir.
Lang, tingnan natin, pwede natin i-200. Ayan, mukhang mas okay to. Yun. Alright. So, itong turbojet, yan. Ito siya. So, kung makikita nyo, walang reciprocating parts. So, ang mangyayari, dito lang papasok yan. Dito sa labas, yan. Dito sa dulo yan lalabas. Kung makikita mo, sir, para saan to? Ito yung tinatawag nating afterburner. So, paglabas sa exhaust mo, mainit pa, nag-spray pa ng dagdag fuel for an added boost. Sir, paano napapagalaw yung turbines? Mamaya, makikita nyo. Pero, to say this a bit, the turbine blades are moved by expanding gases. So, makikita nyo dito yung picture ng turbina natin. Ayan, makikita yung may mga blades, di ba? Parang sa electric fan. Makikita nyo yung blades niya, hindi siya straight, kurbado yan. It is installed at an angle so that when the gas expands, it will hit those blades and turn them. Kuha? Sige, dito muna tayo sa turbojet. Yan. Okay. Turbojet. Kasi nagkakaroon ka ng jet propulsion sa dulo. Pag sinabi nating turboprop, prop is shortened for propeller. This is also a turbojet that is connected to a propeller. So, ito yung makikita nyo makalumang eroplano. Yung nasa harap yung LSE. Ayan siya. Dahil lang natin to. So ito, if we're going to draw this turbojet, yan. So ito, kunyari yan yung body niya. So, dito lalabas yung kanyang, dito lalabas yung exhaust mo. Yan. Diyan siya. So, nangyayari, dito pumapasok yung hangin mo. So, mamaya, i-ano natin yung parts. Tapos, syempre, dito sa loob, yung may combustion ka dito. Yan, preview lang muna para hindi kayo masyadong ano. So, ganyan siya. Okay, yan lang muna for now. Okay? Pero, mamaya, we'll expand on that. Ito, turbojet spins a shaft linked through a transmission gearbox. So, ito, dahil nga meron kang propeller na nakakabit sa kanya, ito, plus mo sa isang propeller. Ba yan? Ayan. Pag dinagdag mo yan, kakailanganin mo ng gearbox kasi may transmission yan. May shaft pa rin yan sa loob eh. So, yung shaft mo, kailangan nakakabit siya sa isang gearbox. So that ito, yung shaft nitong propeller mo, yung shaft niya, mapaikot to. Yan. So, yung ikot nito, matatransmit dito sa gearbox. Using, well, kaya nga siya tawag na gearbox kasi gagamit siya ng gears. Pagpasensya nyo na drawing ko ng gears ha. Hindi super accurate. Ayan, so kaya ganyan na lang. Alam ko mukha siyang sunflower. Yan. Tapos lagay pa natin lang mas maliit na gear para ano. Yan, kunwari ganyan. Pasensya nyo na. So, ito yung nakakabit siya sa gearbox. Your propeller will turn, and so if your propeller will turn, it will generate thrust. Doon siya lilipad. Yung mga makalumang eroplano, hindi lang. Hanap na tayo Cessna na eroplano. Ayan. Yan lang, images natin. So, nakikita nyo, yan lang, hanap tayo ng malaking picture. So, di ba nakita nyo yung propeller yan? Ayan siya. Yung nasa loob na ito, ang nasa loob niyan is a turbo engine, a turboprop. So, ito makikita mo ito yung tambucho niya. Ayan. Nasa loob lang, hindi kita. Ano natin? Yung maliit. maliit siya. Dapat malaki. Natin. Ayan. Hindi. Piston to eh. So, this is not a, hanap tayo ng turboprop. Hindi piston yan eh. Wait lang. Yung malaki para kitang-kita nyo. To. Yan. So, ganito yung turboprop. O, diba? Konti na lang pinagkaiba doon sa drawing ko, no? So, ito. Ito yung gearbox. Ayan. Ayan yung gearbox niya. So, ngayon, mangyayari. This is your compressor side. You have your compressor side here. Papasok yung hangin. Iikot niya tong fan blades mo. Yung turbine blades. So, syempre, lilit yung volume, mako-compress. Pagdating dito sa part na to, dito ka magkakaroon ng fuel injection sa combustion chamber. Yung pagsabog niyan, wala siyang ibang pupuntahan kundi dito sa another turbine blades mo going to the exhaust, iikot na naman siya. So, on one side, nagpapaikot ka or pinapaikot siya using fresh air. After it reaches the combustion chamber, ito yung nagbibigay ng propulsive power sa iyong engine. So, pagsabog niyan, syempre dito lang lalabas yan. Biglang lalabas yan. So, ito na ngayon yung exhaust mo. Nasusundan ba?
Sir.
Okay. So, yan. Edi, ano ko naman mamaya yan. I-send ko lahat ng links ng ginagamit natin ngayon. So, yun yung turboprop. Ito, yung turbofan engines natin. Ito, world's best turbojets paired with turbofan engines. Ito, may duct fan lang siya. So, ang ginagawa lang nito, may dagdag siya na mas pressurized ngayon yung pagpasok ng hangin sa loob ng combustion chamber, ng compressor mo than your combustion chamber. More charged air meaning there's more fuel that you can burn. Mas malakas yung tulak. Itong fan, it also cools down. So, ano natin? Hanap tayo ng turbofan. Pwede ka naman may ano to. Yan. Ito, yung turbofan. Ito. So, ito, ayan yung fan mo. Tapos, meron kang, may parang shroud. Shroud ang ano dyan. May shroud na nakalagay. So, ito yung ano mo. Ito yung cycle mo. You still have intake, compression, power, then exhaust. So, ito yung fan. It provides pressurized air into your compressor. So, di ba, atmospheric, mababa lang ang pressure. When it goes to the compressor, tumataas. Ngayon, if you have already a pressurized source, pagdating sa compressor, tataas ba o bababa yung pressure mo? Tataas siya o bababa?
Tataas po.
Yun, very good.
Tataas.
So, ngayon, mangyayari, if you have a higher pressure of air, pagpasok mo ngayon dito sa combustor at nag-inject ng fuel at in-ignite yan, mas malakas ngayon yung explosion mo. So, ang mangyayari, it will again turn your turbine as it exits your the turbine casing. Ngayon, bakit may nakalagay dito na mixer at nozzle? For added power, ito yung sinasabi ko kanina, that fuel is also injected after the exhaust kasi sobrang init pa niyan. It's enough to ignite your fuel and therefore there's a secondary combustion happening at your tail end. So, mas malakas yung tulak. Ayan, ito yung itsura ng fan. Okay. Ito yung sinasabi niya lang sa turbo fan mo na the air helps pressurize the incoming atmospheric air. Yung fan helps pressurize the incoming air. And at the same time, itong shroud niya dito, it has air passages so that it can help cool your machine down. Na may maintain niya yung structural integrity. Kasi pag sobrang init pa pwedeng matunaw or pwedeng mag-fail. So ito na may maintain niya yung integrity ng makina mo. Okay, mamaya natin we can go about it later. Sasend ko rin naman sa inyo to mamaya. So yan, this goes for all of the turbines. Pag sinabi mong rotor, Pag sinabi mong rotor, umiikot ba siya o stationary?
Umiikot po, sir.
Yes.
Umiikot, sir.
Very good, umiikot siya. From the name itself, rotor. Ngayon, yung stator, ano siya?
Yung buo yung nakatigil, sir.
Yes, very good. So, mangyayari, ito yung direction of rotation. So, if we're going to look at it, magiging, kung kunwari sabihin natin, ito yung turbine blades mo. Kunyari, ito yung harap ng turbine. Yan. Tapos may blades ka, ganyan. Kunyari lang naman. Kung ang direction of rotation niya dito is going up, gayahin ko yan. Saan kaya papunta yung rotation ng blades ko? Is it clockwise or counterclockwise?
Counter, sir.
Very good, yes. This is going to be a counterclockwise motion ng rotor mo. So, mangyayari, itong stator and rotor, pag ikot ng blades mo, pag tulak ng airflow niyan, going counterclockwise. Your stator will not turn. Diyan lang siya. So, mangyayari, pag tawid ng hangin dyan, aangat ulit siya. Then, there's another set of rotors behind it. So, iikot na naman, itutulak naman niya pataas. So, ngayon, na nangyayari, yung ikot, isa lang ang direction of rotation ng iyong rotor. Isa lang yan. Okay? So, sige, we'll continue later on. Tapusin muna natin yung types. Turbo shaft naman ito. Turbo shaft. Ito, madalas ito ginagamit sa helicopters. Yan, lakayan natin. Ito. Ayan. So, ganito yung itsura sa helicopter. May iba pala dito no? Ayan, dami pala dito. Ayan, ito yung sa turbo shaft natin. Ito, the biggest difference is engines use the bulk of their power to spin the turbines instead of driving them out of the rear of the vehicle. Turboshaft engines are turbojet motor with a large shaft connected to the back. So, sa likod nakakabit. Sa likod daw, pero dito sa harapan. So, makikita nyo dito, ito yung compressor side. Ito yung compressor side mo. Combustion chamber, then meron kang core turbine, then power turbine, then dito lalabas yan. Pag umikot to, iikot din yung shaft mo, output shaft, and yung transmission mo dito, magpapaikot ng iyong helicopter. So, katulad na ito, yung sorry. Yan. Di ba meron kang shaft dito? Yan. Mas meron kang gear. Nyari yan. Huwag nyo na lang masyado isipin yung pagkakagawa. Yan. Tapos, meron ka rin ditong gear na nagme-mesh dyan. Dito. Tapos ito na yung helicopter mo. Yan, kunyari ganyan na lang. So ito pag umikot, so syempre iikot to, iikot din siya. Iikot yan. Kuha. So ngayon, yung rotational motion mo dito is generated from the expansion of your gases at the same time, the influx of air into your compressor. Isang direction lang ang ikot niyan. Ngayon, bakit hindi natin nilalagay or ba't hindi nakalagay output shaft dito sa exhaust side ng iyong turbine? Bakit kaya? Ano kaya sa tingin nyo? Ano kaya mangyayari pag yung output shaft ay nasa exhaust side? Dito. Ano kaya mangyayari na sa gearbox? Sige. Do you have any idea? Yes, Javier. Masisira siya sa kalaunan. Pero ano yung magkukos ng pagkasira niya? Ano bang meron sa exhaust side? Yes, yung init. So if it is continually exposed to the heat, tapos wala siyang cooling, ano kaya mangyayari? Yes, very good. Magde-deform yung shaft. Kasi pumipihit yan eh. Pag lumambot yan, syempre hindi, magiging uneven ngayon yung characteristics nung shaft mo. So ngayon, magkakaroon ka ng delay. Or, sa sobrang init niya, well yes, lalambot talaga yan. Pwede rin siya mabali. So yan, so ito yung mga kailangan yung malaman or at least yung the thoughts behind why things are built the way they are built. Okay? So, since 30 minutes na, let's take yan. So, ito may shaft yan. Ay. May shaft yan dito. Ay, ayusin natin yung pagkakadrawing. May shaft yan. Ay, huwag natin dito lagay yung shaft. Yan. Tapos dito, meron kang compressor. Ayan. So, shortened version lang yan. So, ito, yung shaft mo. Siya yung magpapaikot. Siya yung nagkakabit sa lahat. So, ito, mangyayari dito. Pag nagkaroon ka ng apoy, nagkaroon ka ng explosion, dito lahat pupunta yan. Wala siyang ibang pupuntahan kundi yung space na to. Yun ngayon yung nagpo-provide ng tulak. Yan. So, ito, napupunta siya dun. Forward. Ito yung nagbibigay ng propulsive characteristics niyan. So, ito yung exhaust nozzle mo. Ito yan. Nandito banda yan. So, ito yung turbine. You have the compressor here. You have the shaft. So, yung shaft mo, yun yung nakakabit sa gearbox if it's a turbo propeller. Or, if it is a turbo fan. Kuha. So, ito yung itsura ng compressor mo. Ano napapansin nyo dun sa fan blades niya? Sa turbine blades? Ano napapansin nyo? Ano napapansin nyo doon sa size niya? No, makikita nyo, initially malaki. So ito yung you can say that this is passing through stages. So ito yung malaki mo. Low pressure stage yan. As it goes smaller, tumataas na high pressure stage na yan. So ganito yung itsura ng iyong compressor sa turbine. So, ito may ibang types ng compressor. You have the axial. So, on its axis to. So, this is an example of that axial. Yung centrifugal naman, it is used for heavy industries. Yung mga malalaki to. Sa mga planta. Pero kung kunwari sa mga eroplano, for propulsion, mas maliit. Mas maliit yung binibigay. Or mas maliit ang kailangan natin. So, ito naman yung ating mixed flow. This is a combination. Ito, gamit ito diagonal airflow. So, we don't have to get into too much detail kasi ano siya. Well, naka-slant nga siya. Sige, hanap tayo ng mixed flow compressor para meron tayong Meron tayong picture. Ayan. Ayan lang. Okay, ito siya. So, makikita nyo yung pagkakadesign ng makikita nyo yung blades niya, hindi pare-pareho ng itsura. Kaya siya tinawag na mixed flow. Kaya eto. So, meron kang diffuser, then meron ka ring impeller. Ito yung mixed flow. Kasi combination siya eh. Makikita nyo to sa mga turbocharger. Pag maghanap tayo ng, ng exploded view. Musunod. Pero ito, yan. So, ito yung mixed flow mo is a combination of your axial and your centrifugal. So, it's going to get the best of both worlds, pero konti lang ang magiging problema niya. Kasi, yung combination ng dalawa is supposed to cover for the lack of the other. Ito lang ang ano niya. Kinukuha niyo yung main advantages. Kaso nga lang, the exit diameter should be relatively large, making it a problematic design configuration for many applications. So, hindi siya laging pwedeng gamitin sa lahat ng applications. Kasi, you'll have to make it proportionally larger. Mas malaki. So, meaning it will take up space. Kapag sa centrifugal design pala. Okay? Sa mixed flow, hindi. Hindi siya nagsasuffer dito siya issue na to. So, yung disadvantage ng centrifugal mo is naka-counter ng mixed flow kasi hindi mo kailangan ng gano'ng kalaking espasyo. Next is you have the combustors or combustion chamber niyan. So, ito meron kang can. No, parang lata-lata yan. Cannular. Ito. So, makikita nyo yung can, independent siya from each other. Yung cannular, isang buo. Yung annular, yan, ito yung maliliit na yan. So, dito sa can, pag sumabog, ito yan. Diyan lang, contained lang siya dyan, tas dito lalabas. Yung cannular, ito na, makita nyo na space. So, ito yung explosions mo. At yan, it fills up the volume. Yung annular mo maliliit na. Sige, ano natin yung annular. So, ito. Medyo mahirap siyang i-make out initially. Pero, tingnan natin nasaan. Ito yung inner casing ng combustion mo. So, makita mo may mga veins na siya. Yan yung nagsiseparate. So, kung makikita nyo, parang isang buong, ito na yun, yung buong space na yan, ino-occupy na niya. Ayan siya. Parang ito yung combustion mo eh. So, ito yung can-annulated or cannular. To. An annular combustion system is a single continuous donut shape. Isang buo yan. Isang buo siya. Pag yung can, lata-lata. Kanya-kanya yan. Yung can-annular, kalahati siya. So, it takes both characteristic from your can and your annular. So, may part siya na lata, isang buo, may part siya na separated din, pero interconnected pa rin siya sa iba't ibang dun sa ibang cans o dun sa ibang chambers. So, ito depende naman yan sa application. So, saan ba ginagamit yan? Yung annular and yung can-annular or cannular, ginagamit siya on smaller scale applications. Sa mga eroplano. Yung silo combustors, ito yung mga malalaki. So, ito yung ginagamit sa mga planta. Okay? Naiintindihan ba? Nagigets? Nasusundan? Okay. So, next natin yung turbine. Yung turbine mo sila different different categories. So, kung titingnan natin yung gas turbine parts. Ito. Hanapin natin yung picture. Dapat may picture to eh. Wala siyang picture. Natin. Wala. Ayan, di bale. Ito na lang. Ito yung parts niya. Wala rin picture Ito, yan. So, kung titingnan nyo, medyo komplikado siya, no? Komplikado yung itsura niya. Maselan to kasi kailangan nito lahat ng parts mo makinis. Hindi pwedeng magaspang dito. Ngayon, dahil very fine yung kanyang clearances, kapag yan nasingitan, pwedeng mabali yung veins niya. Pag nabali yung veins niya, tuloy-tuloy na yan kasi babara siya dun sa umiikot. So, dudurugin niya yung nasa loob. Mukhang mas maganda ata papanoorin ko kayo ng video sa...
A gas turbine operates by drawing in fresh air.
Yan.
Are turbo generators and turbo compressors.
Wait, lakasan natin. To. Para makita niyo yung moving parts niya.
I try to approach a gas turbo generator, or GTG, to better feel the subject. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new Real Pars videos. This way, you never miss another one. In a gas turbine power plant, there's a generator, which is an electrical machine. But to generate electricity, this generator needs a prime mover, which, for my example, is a gas turbine. The gas turbine transforms the chemical energy in the fuel, for example natural gas or similar fuel, into mechanical energy. The mechanical energy generated by the turbine exit shaft is then transferred through a gearbox to the generator's shaft. Now, my generator can create electrical energy. This primitive form of electrical energy normally has a low or medium level of voltage, and to better manage the power loss in transmission lines, this voltage should be increased by step-up transformers. Such transformers give an adequate level of voltage to the electrical energy to be transmitted through the transmission lines and delivered to the grid. After this brief overview of a sample gas turbine application, I'm going to dig down into the gas turbine mechanism in more detail. First, imagine a rocket in which some fuel is going to burn and create a high-pressure exhaust gas. Based on energy conservation law, the chemical energy of the fuel is transformed into mechanical energy in the high-pressure exhaust gas. When a rocket is fired, the thrust of this exhaust gas moves the rocket forward. This amount of rocket science is enough for me. And now, suppose I fix the rocket body with a robust mechanical structure to prevent its movement. What will happen? The high-pressure exhaust gas should be released, and it will have no way but backward. Now, keep this structure in mind, and imagine I put a set of turbine blades in the path of this high-pressure backfired exhaust. You see that the release of mechanical energy, which is mostly in a linear backward direction, will mostly transform into a kind of rotational movement of the turbine shaft. And so far, I'd say it's a big success. In that, we've transformed the chemical energy of fuel gas into rotational mechanical energy of the turbine shaft. Now, I have a prime mover for my generator in the above power plant example. Also, this prime mover concept can be used in different applications like turbo compressors or the like. Now that I have the basics of gas turbines, let's focus on a modern gas turbine and its components. Most likely, you know about fire triangle or combustion triangle, which illustrates the necessary ingredients of fire or combustion. In other words, fuel, air, and heat. To transform the chemical energy of the fuel gas into mechanical energy, the fuel should be burnt in the combustion chamber of a gas turbine. So I need air and heat added to the fuel. Air is let into the gas turbine through an air intake and mixed with a proper amount of natural gas. The air-gas ratio is determined based on the specific heating value of the gas and quality of the air, amount of moisture, altitude from sea level, and so on. Now, an ignition system steps in and makes the initial sparks, whereby heat is provided. When the fire is established and stabilized in the combustion chamber, the ignition system will be put out of service. The most critical process in normal turbine operation is to manage the combustion and produce a proper amount of high-pressure exhaust gas. This exhaust gas is applied to the turbine blades, and after rotating the turbine shaft, conducted to the exhaust stack. With this quick review of key components of a gas turbine, I think it's time to decrease the altitude and elaborate on the system further. As I mentioned earlier, air is let into the gas turbine through an air intake. The air is prone to contamination or having some unwanted particles which can harm the system and degrade the overall performance. The screening and filtration are basic requirements for incoming air. Also, proper instrumentation is mounted on the air duct to monitor the draft pressure and temperature. In harsh environments, the air might need to be preheated or conditioned. Also, differential pressure monitoring of air filters will warn the turbine operator of filter clogging. The conditioned air is conducted into the turbine air compressor, which is an axial compressor comprised of multi-stages of blades mounted radially on the turbine inlet shaft. The discharge pressure and temperature of the air compressor are monitored to manage the combustion quality at the combustion chamber. Fuel gas is a key factor in the design and operation of a gas turbine. The manufacturers need to know the details of fuel gas, and only based on its characteristics can they guarantee the performance of their gas turbines. Also, the pressure and temperature of fuel gas are monitored during normal operation of a gas turbine. There are different technologies in properly mixing the air and gas and making efficient combustion from manufacturer to manufacturer. Combustion chambers are of some tubular heat-resistant structures, and fuel is usually injected into it from the circumference and at different cross-sectional locations. The temperatures at different locations of the combustion chamber are thoroughly monitored by means of proper sensors like thermocouples. This high-temperature, high-pressure zone in a gas turbine structure is of the highest levels of importance to monitor and control. Also, the technologies used in the design and construction of the combustion chamber are of the topmost ones. Now that the air-gas mixing is well managed and combustion is going on properly, there is plenty of high-pressure, high-temperature exhaust gas generated and should be applied to the gas turbine blades to make turbine exit shaft rotation feasible. At this stage, the high RPM of the gas turbine rotor should be tightly monitored, and based on the load driven by the turbine, the surge of turbine gets the topmost importance for turbine performance and turbine protection. Vibrations, axial and radial, and speeds, both at the air compressor and gas turbine, should be continuously taken into consideration. This was the simplest way to address major parts of gas turbines, and as one of the most sophisticated man-made machines, a gas turbine deserves more elaboration. Also, there are different technologies which some manufacturers use as their proprietary technology, and were not considered in this video. Want to learn PLC programming in an easy-to-understand format?
Do you have any questions or any insights dun sa napanood ninyo tungkol sa gas turbine? Ito, dagdagan natin how gas turbines work.
A lot of gaseous molecules floating all around us. It's great for breathing, and it turns out it's great for getting lights turned on. That's because air, along with abundant natural gas or other fuels, are the ingredients that combine in a gas turbine to spin the generator that produces electric current. If you follow the electricity you use at home or at work back through the power lines to your local power plant, you'll see that the process most likely starts with the work of the gas turbine, the very heart of the power plant. First, air is drawn in through one end of the turbine. In the compressor section of the turbine, all those air molecules are squeezed together, similar to a bicycle pump squeezing air into a tire. As the air is squeezed, it gets hotter and the pressure increases. Next, fuel is injected into the combustor where it mixes with the hot compressed air and is burned. This is chemical energy at work. Essentially, this is what happens in your family car's engine, but at about 2,900 times power.
Actually, it's exactly like the turbine engines on jet airplanes. The hot gas created from the ignited mixture moves through the turbine blades, forcing them to spin at more than 3,000 RPMs. Chemical energy has now been converted into mechanical energy. The turbine then captures energy from the expanding gas, which causes the drive shaft, which is connected to the generator, to rotate. That generator has a large magnet surrounded by coils of copper wire. When that magnet gets rotating fast, it creates a powerful magnetic field that lines up electrons around the coils and causes them to move. The rotating mechanical energy
Has now been converted into electrical energy because the movement of electrons through a wire is electricity. In what's called a combined cycle power plant, the gas turbine can be used in combination with a steam turbine to generate 50% more power. The hot exhaust generated from the gas turbine is used to create steam and a boiler, which then spins the steam turbine blades with their own drive shaft that turns the generator. What you end up with is the most efficient system for converting fuel into energy. And that's your GE Gas Turbine 101.
Okay, so since 30 minutes na rin ulit yung nakalipas, okay, I'll give you a 10-minute break para makapag-unat-unat at makapag-refresh. So, please be back by 15:25. Okay? Be back by 15:25. We have discussed about the main parts. Then, yung processes is actually it's still no different from your reciprocating engines. Ganun pa rin naman siya. You have your intake, you have your your compression, combustion, then exhaust. It still follows the same sequence of events. Ngayon nga lang execution niya nagkakaiba. So instead of a reciprocating piston, you have vanes. You have may rotary motion para naman siya, unlike yung reciprocating kasi. You have an explosion that pushes the piston down. Then that piston is connected to a crankshaft which provides rotary motion. Ito, it removes that extra part ng up and down. Ang nangyayari dito, you have an explosion, you have combustion, and the direct motion of that gas escaping that chamber pushes the blades to rotate. So, direktang rotary motion na siya. Naintindihan? Nasusundan? Nasusundan ba? Dahil ang gas turbine, 4 types, components. Ito. Ayan siya. So, meron kang shaft, output shaft. You have the exhaust here. Ito, meron kang turbine just before the exhaust. Combustor, compressor. Yung output shaft mo, dito siya nakakonect sa malapit sa compressor side. Yun lang kasi ang pwede mong kabitan. Hindi mo pwedeng kabitan yan dito sa exhaust kasi maluluto yung whatever automation and instrumentation you have. And syempre, kung dito ka mag-ooperate, kunyari ito, kinabit mo dito at mag-ooperate ka. Ano sa tingin nyo mangyayari sa operator pag nandun siya malapit sa exhaust na nag-ooperate?
Ano ulit, sir?
So, kunwari, di ba itong, meron ka dito, ito yung output. Yung output shaft mo, ilipat natin dito sa kabilang dulo. Tapos ito, kunwari generator to, nandito yung generator sa kabilang dulo. Ngayon, kung mag-ooperate ka, ano kaya mangyayari sa, ano kaya? Yes, no, cause may made-deform. Yes, mag-overheat. Mag-overheat yung makina mo. Eh, doon sa tao, ano mangyayari?
Bubugahan ng init.
Ngayon, kung may expose kayo for long periods of time dun sa init na yun,
Madidrain, sir.
ano pa? Gano'n kaya kataas yung ano? Oh, yes, Javier, nakakamatay. Maluluto kayo dyan. Draining and drying up will be the least of your worries kasi maluluto kayo. So, gets? Gets yun, ha? Actually,
Sir.
Isasend ko rin naman sa inyo tong links nito so that you can view them at your leisure. So ito, meron kang fuel injectors dito, meron din yung igniters so that yung na-compress sa air dito kasi it's not enough to ignite the fuel on its own. Kahit na sabihin mong mas refined siya kaysa sa diesel. Kailangan pa rin ng igniter niyan. So, asan ba yung... Ito ba yun? Hindi lang.
Around 80 years ago, the world...
Ayan, sige, ano natin to. Full screen natin siya.
First industrial gas turbine began to generate electricity in a power station in Switzerland. By 1960, the most powerful gas turbine reached 20 megawatts of power. And today, their power in combined cycle increased to around 600 megawatts, which is almost the amount of electricity a city like San Francisco consumes. And their efficiency increased to more than 60%. They are ideal for peak power because they can produce energy almost instantly. And here's a quick look at how they work. A gas turbine usually consists of three main parts: compressor, combustor, and turbine. At first, the air is drawn inside the compressor. Inside the compressor, the air is squeezed, similar to a tire pump that squeezes air inside the tire while the air's pressure and temperature rise. Then it enters the combustor. In the combustor, the fuel is injected into the air, and its combustion produces a lot of energy and increases the air pressure and temperature remarkably. This is similar to what happens inside a car's engine. This extremely hot and pressurized gas will go through the turbine blades and will cause the turbine's shaft to rotate to more than 3,000 RPM. This energy will go from the shaft to a generator to produce electricity. The gas turbine is exactly like a plane's jet engine, with one difference: that a gas turbine used in power generation has large blade rows in the turbine part to convert the hot gas flow to rotational power in its drive shaft to run a generator. But an airplane engine ejects most of the hot gas to create thrust. In combined cycle power plants, gas turbines work in combination with steam turbines. The hot air in the exhaust of a gas turbine is used to generate steam for a steam turbine. This increases the power and efficiency of the power plant. Nowadays, the efficiency in a combined cycle has reached a remarkable value of more than 60%. And this is how a gas turbine works.
Ayan. So, well, hindi naman siya nga nagkakaiba. Pero ito kasi, instead of having that reciprocating motion, direkta na sa rotary. And comparing them sa efficiency, if you will notice na mas marami pa ring barko ang gumagamit ng diesel engine, it means that the efficiency is still higher for your marine diesel engines compared to your gas turbines. Mas mataas pa rin. And construction of a gas turbine is actually more expensive, including its maintenance and care. compared to your diesel engine. So yan, makikita nyo yung kita mo, di ba, ang kintab, corrosion free. You cannot achieve that kind of cleanliness if you are sailing out at sea. Kasi magkakaroon ng asin at magkakaroon ng corrosion yan eventually. Dahil dyan. Kaya hindi siya talaga ginagamit for or widespread sa sea or ocean travel. Okay. Do you have any questions? Ito, meron tayo dito na, actually, na-hit na natin yung 1, 2, and 4. 1, 2, and 4, na-hit natin. So, let's look at your steam turbine naman. Ano naman ang pinagkaiba niya? So, ito, yung steam turbine nyo naman, instead of exhaust gases, ang driving mechanism niya dito, it's actually steam. Well, kaya siya tinawag na steam turbine. So, wala siyang combustor, wala rin siyang compressor. Wala rin siyang exhaust. So, this is an example of your steam turbine. So, yung parts niya. Ito. Cutaway view yan, itsura. So, let's go to the parts. So, yung steam chest and casing. So, dito nakakabit yung supply. Supply mo ng steam. It also houses your turbine, saka yung ibang parts niya. So, yan, you have a rotor. Ito yung umiikot. Bearing cases, ito yung lalagyanan mo ng mga bearing kasi dahil umiikot yan, kailangan smooth. So, itong bearing cases mo, nakakabit yan sa shaft. Casing sealing glands, kasi nga pinapasok siya ng steam para hindi tumakas yung steam at mawala yung power, kailangan selyado. Yan yung casing sealing glands mo. Yung governor system, it tells your turbine how to go fast or how to go slow. Dito mo siya pwedeng palitan ng speed setting. Ito marami yung I think it's better it's better shown through a video. Kasi marami siyang marami siyang laman. So tingnan natin kung ito, steam turbine. So, do you have any questions?
Wala naman po.
Wala naman. O, sige. Ito. Steam turbine. Compared sa mga gas turbine, mas marami na mga steam turbine na ginagamit. Though it's not as still widespread. So, ito. I-full screen natin para kitang-kita lahat. Tingnan nga natin kung English to.
The function of a turbine is to convert energy contained in steam to mechanical energy that is used to turn a generator. A turbine is an enormous machine and may seem indestructible, but in fact, a turbine is easily the most delicate and precise piece of equipment in a power plant. To operate a turbine safely and efficiently, it's important to have a basic understanding of turbine construction and operation. In this part, we'll take a look at the various components of a turbine. As we do, we'll be using common names for turbine components. Keep in mind, however, that your plant may use different designations depending on the manufacturer of your turbines. This is a diagram of a simplified steam turbine. Turbines are composed of moving parts, stationary parts, and systems of pipes and valves. We'll start with the moving parts, the shaft and the wheels. The turbine shaft runs the entire length of the turbine. This end is connected to the generator. The turbine wheels are connected to the shaft. A turbine wheel consists of a round hub and rotating blades, or buckets as they're sometimes called. The shaft and the wheels are collectively called the rotor. The rotor is supported by bearings and is housed in a casing which is sometimes referred to as a cylinder. Mounted to the turbine casing are diaphragms. They are positioned in the casing between the wheels. The casing and diaphragms are stationary parts of the turbine. Diaphragms are similar to wheels in that they are round hubs and they have blades. The diaphragm blades are sometimes referred to as nozzles. The distinction between diaphragms and wheels is the way they function during turbine operation. Diaphragms are stationary, and their blades are fixed in position. Their function is to direct the flow of steam leaving one set of rotating blades into the next set of rotating blades. Wheels, on the other hand, are moving parts. They are designed to turn as the steam flow passes through their rotating blades. The rotation of the wheels turns the shaft and the generator. Diaphragms are sealed where the shaft passes through them to minimize steam leaking through this opening and bypassing the diaphragms. Typically, the pairing of one diaphragm and one wheel is called a stage. A turbine may have up to 25 or more stages. Our example shows 8 stages, but only 7 interstage diaphragms. There's another diaphragm before the first row of rotating blades. This diaphragm is called either a nozzle block or a nozzle box. As with the interstage diaphragms, the nozzle block houses a series of stationary blades that are sometimes referred to as nozzles. The diaphragm nozzles direct the steam from the steam inlet to the rotating blades of the first wheel. The steam then proceeds through the remaining stages of the turbine until it is exhausted into the condenser. Now, before steam can enter the turbine through the steam inlet, it must pass through 2 types of valves, stop valves and control valves. Stop valves, which are also called throttle valves, remain fully open during turbine operation. The principal function of stop valves is to shut off the steam supply to the turbine during a shutdown or under emergency conditions. Control valves are used to regulate the amount of steam flowing to the turbine. For this reason, control valves are sometimes called governor valves. Under normal conditions, the control valves are partially open to regulate steam flow during operation. Steam flows from the stop valves to the control valves through pipes. Depending on the turbine design, steam may also flow through a steam chest. A steam chest allows the steam to spread out and slow down so that the flow will be less turbulent as it enters the control valves. In this part, we'll take a look at how turbine rotation occurs. As you may know, the function of a turbine is to convert the energy contained in steam into mechanical energy used to turn an electrical generator. This conversion is achieved by one of 3 methods: impulse, reaction, or most commonly, by a combination of both. While the end result is the same, the method of producing the result is quite different. Impulse blades work in a manner similar to the blades of a pinwheel. Air traveling in one direction strikes the pinwheel blades and pushes them out of the way, causing the wheel to turn. With turbine impulse blades, a similar thing happens. This simplified illustration shows the configuration of turbine impulse blading, with the rotating blades and the stationary blades or nozzles. As high pressure steam is forced through the stationary blades of a diaphragm, it speeds up. The steam striking the rotating blades causes the wheel to turn. Since the wheel is attached to the shaft also rotates. Reaction blades work differently. With reaction blading, the speed of the steam's movement causes the rotating blades to turn. This is easier to understand if we look at how a rocket engine is designed. This simplified illustration represents a nozzle that is part of a rocket engine. Hot gases from the combustion of fuel are exhausted through the nozzle as they leave the combustion chamber of the rocket. The nozzle causes the hot gases to accelerate to a high speed as they pass through the nozzle's narrow throat and then expand. The high speed creates a reaction force on the rocket engine that is in the direction opposite to the movement of the gases. This reaction force propels the rocket engine. In a turbine, the moving reaction blades act like the nozzle in a rocket engine. Steam leaves the blades at high speed and creates a reaction force on the blades, and that causes the wheels to turn the turbine shaft. Most modern turbines combine the use of impulse blades and reaction blades to make the most efficient use of the energy in steam. It is the designer's job to determine the proportions of each type of blade required in a turbine. Most large turbines are almost pure impulse in the first stage, almost pure reaction in the last stage, and a combination of the two in between. Now, you won't be designing turbines, but understanding what's going on inside will make you better equipped to operate them. So far, we've been talking about a simplified turbine. Most large turbines are divided into sections, and each section is connected to a common shaft. In this illustration, there are three separate turbine sections: a high pressure or HP section, an intermediate pressure or IP section, and a low pressure or LP section. At times, the different sections are referred to as separate turbines: the HP turbine, the IP turbine, and the LP turbine. But operationally, they all make up one turbine. In another turbine design, the sections are connected to different shafts. In this example, the HP and LP sections are on one shaft, and the IP section is on another shaft. This arrangement is called cross-compounding. While each section of a turbine works according to the same principles, they are not identical. By the time steam has traveled from the high-pressure section to the low-pressure section, its volume may have increased as much as 150 times. The size of the turbine is increased. Second, some of the steam is removed from the turbine by an extraction steam system. The extraction steam is sent to the feed water heaters, where it is used to heat feed water. The steam in the turbine gives up some of its heat as it passes from one stage to the next. For this reason, it's often necessary to return steam to the boiler for reheating before it passes through the entire turbine. This reheating most often occurs between the high-pressure section and the intermediate pressure section. Reheated steam is returned to the turbine through reheat stop valves and intercept valves. These valves, along with the stop valves and the control valves, also provide protection for the turbine. As you know, turbine speed is regulated by the control valves. If turbine speed increases during normal operation, how do you think the control valves will respond? If turbine speed increases, the turbine control valves will compensate by closing. Under certain unusual conditions, the turbine may begin to overspeed. That is, the turbine may begin rotating at a rate higher than it was designed to handle. An immediate danger exists that the turbine speed will increase to a point at which centrifugal force will break it apart. This is where reheat stop valves and intercept valves help to protect the turbine. If the turbine begins to speed up, the control valves will compensate by closing. However, there is still a great deal of steam in the reheater section of the boiler. This steam will continue to flow through the turbine, causing it to speed up. To prevent overspeeding, the intercept valves close, cutting off steam from the reheater. If for some reason the speed continues to increase, the turbine trips. When the turbine trips, all four types of valves, the stop valves, the control valves, the reheat stop valves, and the intercept valves, quickly close, cutting off all steam to the unit. A trip protects the turbine from danger by immediately shutting off steam flow to it.
Okay, do you have any questions? So, okay. Madi-differentiate nyo ba yung operation ng steam turbine versus sa gas turbine? Just give me examples. Anyone? Sige, si Sura Vasquez. Si Andre. Can you give me an example on the differences between a gas turbine and steam turbine? Meron ba makakapagbigay? Sige, let me check the... Yes, go Javier. You can either type or unmute.
Yung sa pagkakaalam ko po, yung pagkakaiba po ng dalawa, ano po kasi yung, di ba po gas yung steam? Yung gas, yung steam po, ako baga yung ginagamit niya lang po, steam lang talaga. Tapos yung gas, yun, syempre gasolina, tsaka petroleum, ganun po.
Okay, sige. Sige, Nokos, go ahead.
Sir, sa pagkakaintindi ko po, yung steam, ano nga yun? Yung steam turbine, sir, steam lang po talaga siya ginagamit. Steam po yung power niya. Hindi po siya nagamit ng combustion. Tsaka,
Okay, very good.
sa ano po kasi sa gas turbine po kasi gumagamit po siya ng combustion eh. Kaya po sa
Okay, wait lang. Meron bang nag-raise ng hand? Let me check. Wala. So, yes, yan. The main difference... Yes, go ahead, Andre. Sura Vasquez, go.
Sir, yung sa sa steam turbine po, ang ni-utilize nila po is yung steam lang po. Compared dun sa gas turbine, pwedeng ni-utilize niyo po yung petroleum or diesel fuel po, sir. Yun po yung pagkakaintindi ko, sir.
Okay, sige, that's good. That's a good example. Pero, hindi siya gumagamit ng diesel kasi masyadong mababa ang quality ng diesel. What I will want you to do is just look up in Google kung anong klaseng fuel ang ginagamit para sa mga gas turbines natin. Okay? At dahil
Natural gas.
Oh, yan. That's one. Natural gas. So, iba ang characteristics niya compared sa diesel. Okay? So, dahil meron tayong upcoming class sa power plant diesel, so, I will dismiss you first kasi magkikita rin naman tayo. I'll be giving you a 10-minute break bago pumasok ulit. So, thank you for attending PASGT. And i-forward ko na lang lahat itong items na to. Yung mga links na ginamit natin. Okay? Sa kayong recording. O sige, magpahinga muna kayo and I'll see you in PPD.
Thank you, sir.
Thank you very much.
Thank you, sir.